Hi there, welcome to the Food Chase training. I am Professor Rafael Bonato, and during this Smart and Sustainable Food Production System module, I will be exploring specifically the theme related to applying digital tools for efficiency in agriculture monitoring. I hope you enjoyed this class, the module number 8, and you take the best of it, remembering that the written material will be your main teacher here, helping you understanding and dive deeper into the knowledge that will be slightly touching bases here and sharing with you. Let's start our presentation. Learning outcomes. At the end of this module, students will be able to apply digital tools to monitor agriculture systems in a real world, understanding how important such digital tools are and how to use them, use a sensor-based data to support preventive and predictive maintenance, understanding the difference between preventive and predictive, interpret digital indicators to diagnose risks and crops, infrastructure and machinery, integrate digital monitoring into sustainable resource-efficient farming system, and align digital practices with the EU Farm to Fork, say a CAP, Common Agriculture Policy, and Green Deal objectives. Let's start our class. The first chapter of our presentation, the first part, is composed by the introduction to the submodule, which is about to explain that modern agriculture systems integrate biological, mechanical, hydraulic, and digital components. Those last ones really represent the very updated type of agriculture. We normally don't, back in the days, we didn't mention digital components into agriculture systems, but now we see that's essential, okay? Traditional maintenance based on periodic inspection is often insufficient, very often actually, to prevent yield loss, system failure, and resource waste. Digital monitoring enables continuous oversight, something that continues happening, allowing early detection of stress, malfunction, or inefficiency, shifting agriculture from reactive correction to preventive and predictive management. So important, this very last paragraph here, because we see a shift from reactive to preventive and predictive management, which changes totally the way you see the industry, the way you see agriculture, you see the food industry, okay? Next slide, digital monitoring as a pillar of sustainable agriculture. Within the European Union, digital monitoring supports waste reduction and efficiency targets under Farm to Fork strategy. Remembering the explanation of Farm to Fork strategy is within the module, and with the module we can actually click on the link related to Farm to Fork strategy and go to its specific web page and explore this extensive web page that explains what Farm to Fork strategy is composed of, what does it mean, and its influences on the European Union region, okay? Within the European Union, such a digital tools supports a part of waste reduction, climate resilience and adaptive management, understanding the management must be adaptive because the climate is changing, okay? Improve traceability, transparency, and compliance, very important. And by transforming physical and biological process into a measurable data streams, digital tools enable evidence-based decision-making across agriculture systems. There is a very key expression on this sentence, if you see, evidence-based decision-making, very important. My decision-making will be based on evidence-based instead of I thinking this is the way, or maybe that's the way. No, you have numbers, you have a data, you have a history behind you that will help you take the right decision, okay? And here on this on the right-hand side of this slide, we have the digital agriculture on its benefits and challenges, and a graphic that goes about crop productivity and time, how it behaves. This has been extracted from a paper that you can access on the written material, or even on this presentation, just click on the link and access it. It would help you a lot understanding benefits and challenges of digital agriculture, okay? Sensors in agriculture production. The objective of this sub-chapter is to show you that continuous monitor system performance to detect deviations before losses occur. It's important, and it's backed up by sensors that are mainly divided into soil and crop systems, like I have mentioned before on the previous presentation, irrigation and hydraulic infrastructure, machinery and equipment, storage and post-harvest environments. Okay? Sensors, soil sensors and crop growth monitoring, the first subchapter there. Soil sensors provide real-time information on soil moisture, temperature, salinity, and electrical conductivity, like I mentioned before. These data support precise irrigation scheduling, when to irrigate and how much water should I need, or what will be the application of that. Prevent water stress and nutrient leaching. Remember, the leaching is the fact that the excess of nutrient water will be running away from somewhere, maybe percolating on the soil. And improve yield stability under variable climatic conditions. So important. This is a type, on the right-hand figure, is from a paper as well. This is a type of a wireless node that is a sensor that we normally put in the soil to understand humidity, to understand temperature, maybe salinity, electrical conductivity. That helps you. It's a wireless one, like the name says. We can actually communicate directly with the cloud and the cloud with the data application, and helps you having a real-time data to take a decision on the right time. Okay. Regarding plants and canopy sensors, plant-based sensors measure canopy temperature, water stress, if something happens up in there. This is an example here of, I think is a tomato production, maybe apple production, sorry, and helps understanding how or the different levels of the canopy, the temperature is influencing, how to act accordingly to avoid problems. And spectral reflectance as well, to measure biomass and vigor via NDVI and DRE, as well as chlorophyll content, okay? And this paragraph here summarizes that early detection of physiological stress enables timely, site-specific interventions before visible damage or yield loss occurs. We haven't mentioned this in the previous slide, previous presentation, pardon, and it's very important to emphasize here how important it is to understand it before your eyes notice. Let notice on the system before the eyes. Because if you wait to understand, to interpret by visual, maybe the crop is lost already, okay? Infrastructure and equipment monitoring. Sensor also monitor irrigation pressure, flow and uniformity, machinery vibration, temperature load, storage temperature, humidity, and gas composition. And continuous monitoring reduces unplanned downtime, prevents spoilage, and supports operation continuity across production and post-harvest systems. This is very, very important here. As you can see, intelligent detection is a system for fresh food. It's a part of a paper as well. And this paper talks about this intelligent detection and what is it composed of, and how it runs, and how it benefits of a real-time quality testing equipment, intelligent resource tracing equipment, how they act to, when they are integrated, how they positive impact on the fresh food, on the food, decreasing the food waste and delivering a best end of the line product, okay? The next slide is related to the remote monitoring platforms and dashboards. The objective of this module is to clarify that transform sensor data into actionable information through digital platforms that integrate heterogeneous data streams. You have a different heterogeneous data streams of soil, water, production line into one stream that helps you taking a decision on a real time, helps you visualize key performance indicators in real time, like I said before, and generate automated alerts when thresholds are exceeded. Example, temperatures are over 27 degrees, you will be damaging the skin of the fruit. These generate automated alerts for you to take the right decision, maybe irrigate, maybe collect earlier, maybe taking a decision that's more applicable in that case, and this or that case, okay? In this sense, dashboards improve the situational awareness and response speed across complex farming system. Remember, within the farming system, we have many different pillars of production. The dashboards put all together and help me having an overlook over every single pillar and take the right decision that will benefit each of those, or maybe does not cause any harm to the entire system, okay? Digital tools for preventive maintenance. Preventive maintenance here uses condition data to detect performance degradation early, before it actually happens, before it's too late. Schedule interventions before failure, very important as an early warning system, and reduce emergency repairs and downtime. Emergency repairs only happen when you haven't taken the decision previously, okay? Examples include pump efficiency monitoring, pressure differentials in filters, and thermal anomalies in machinery. This table here is part of a paper that's shared with you and shows the emerging technology, food safety risk divided by, in this case, 4 allergies, contaminations, and food fraud, and the other pillar enhanced food safety and other factors. And it actually qualifies on the different levels from no anticipated impact to the high improvement in food safety, high food safety risk, okay? Divided into different colors. This table here is good and very worth exploring to understand how you can actually use this example to qualify the risks you have on your production line, on your farm, okay? Predictive maintenance and failure anticipation. Remember, before you failure, you anticipate to avoid it to happen. Predictive maintenance applies time series analysis to understand what happened in the past, what time series tells me that might occur in the future, okay? Machine learning and anomaly detection. The machine learning helps you project different scenarios to understand what the problem would be in the future, and then you can act accordingly, okay? Remaining useful life, RUL, estimation, how much life I have to use such equipment, and should I substitute any part of this equipment to, stretch the lifespan of such machinery. This helps you a lot. And these tools anticipate failures, allowing maintenance to be aligned with non-critical periods. Example, in between the harvesting processing times, I can set my maintenance because the lines won't be working, or maybe I have more time to think about and operate. They can help you to be aligned with the non-critical periods, like I said, in preventing cascading losses during planting, irrigation, or harvest operation. You don't want to be caught on the harvesting time, stop your machinery to fix it during the harvest time. That will cause a lot of problems, okay? Applying digital monitoring across systems. This figure on the right-hand side has been extracted from an update paper as well that shows the digitalized food system and the components of it, which are basically 3 authorities, food, businesses, and customers, and how such things are interrelated and how the spots and the figures are connected, okay? This paper explores and show you how this food system is interrelated and how important is each of those steps, okay? And in this sense, digital techniques support crop and soil system maintenance, early stress detection. Before the stress occur, you actually act accordingly to avoid or decrease the negative impacts. Helps you support machinery and energy system performance. Helps you with irrigation infrastructure reliability, understanding how reliable it is by understanding when the problem can occur. And helps you post-harvest and storage stability as well. Post-harvest and storage stability as well. Very important. Integrated monitoring ensures that biological performance is not undermined by technical failures, okay? You avoid technical failures. When you're doing the integrated monitoring, you track back all the potential things and you decrease the problems of that type of technical failures to occur. You'll not be avoiding 100% because it's very theoretical, but helps you a lot to control the things that happen here. The other chapter, efficiency and sustainable benefits. Digital monitoring delivers reduced water, energy, and input losses. Perfect. Lower greenhouse gas emissions because you're using the energy, the water, the product itself wisely. Extended equipment lifespan, that's what you want. If you have a maintenance before, you actually save the ball bearings of having problems. Just a quick example. Okay, improve traceability and compliance by having those systems put together. The compliance with a label or certification scheme will be the way easier to be attended if you are compliant with the laws, compliant with the protocols. And these benefits directly support the EU Green Deal and the Farm to Fork strategy, aligning productivity with environment stewardship. Okay, the figure on the right-hand side shows the BCT-based food supply chain and how it's composed by production, processing, packaging, retailing, consumption, waste management inputs, how this cycle works and how it's influenced and transversal to economy, society, and environment. Okay, how it influences and how it is influenced by. It's another page, it's not a paper, it's a part of a page. There is a paper you can access, but it's part of a page that explains each of those sectors, each of those different points, and helps you understand sustainable diet, circular economy, profitability, efficiency, transparency, and resiliency, and so on. Okay? This was our module number 8. You see that we are going more in depth into the technical knowledge here. If you see, we have probably around 6 to 8 different updated papers that is long reading. I advise you to read as much as you can of those papers, because they are very updated papers and they help you understand what's going on the food industry nowadays. And supporting these, we have the written material with all the references, updated ones as well, with books and videos. I have put the links for you to access that will help reinforcing such a knowledge. Okay, I'm Professor Rafael. I'm Dr. Rafael Bonato, and I hope you have enjoyed this presentation, and I'll see you on our class number 9. Have a nice day, and thank you once more for your attention.